Hey everyone, this is Unit 2, Atomic Structure and Nuclear Chemistry, Section 1, Part 2, and this is for Honors Chemistry. Okay, first thing we're going to cover real quick is the isotopic symbol. This is just a symbol that we use to kind of give you as much information as possible about a specific atom of an element. So what we end up with is up here in the top left corner, we have the mass number. Mass number is the protons plus the neutrons. This is very, very similar to the rounded average atomic mass, but the rounded average atomic mass takes into consideration all of the different isotopes of a particular element, meaning all of the different versions of that element. But this mass number is referring to just the version of that element that this particular symbol is referring to. So if we know that the protons plus the neutrons equals 9, that's the mass number. You're not going to use the beryllium average atomic mass, you would use the mass number for that element. It also already has it essentially rounded. So when we actually go to try to figure out number of neutrons using the isotopic symbol, what we see is right here we have the atomic number, and so essentially it's already set up as a math equation because this is protons and neutrons. This is just our protons. We subtract, we have 5 neutrons. Okay, so it's very easy using the isotopic symbol to figure out that information. Okay, we then have the element symbol right here in the middle, and then the top right corner we put the charge, also known as the oxidation state, which we will talk about soon. Okay, so we don't need to know too much about that just yet. We'll get to that in a minute. What I'd like for you to do right now is go ahead and pause this video and practice these three. So you have a sodium atom with 11 protons and 12 neutrons, sodium with 11 and 11, a sodium with 11, 11, and 10. Okay. This last one is going to be kind of our segue into the next lesson. So what I would identify for you and what would be best is to try to run these first two. Okay. So go ahead, pause it, and then as soon as you unpause, I will be going through the answers. All right. So sodium atom. We know sodium, if we use our periodic table, is element Na. Wow, that's an interesting N. Anyways. And so the atomic number is bottom left. Atomic number is protons, so that would be 11. The mass number is protons plus neutrons. 11 plus 12 is 23. We are not told there's any sort of charge, so this one is good to go. The next one, sodium, Na, again, 11 protons. That number would not change because sodium is always 11. This one, however, has 11 neutrons, making it sodium 22. Okay? Notice that it's still sodium, still the same number of protons, slightly different neutrons leads to slightly different masses. The last one we're going to get to, this one would look like this. Na with 11 protons, 11 neutrons, making a mass number of 22, and 10 electrons. Well, we already said that we know that electrons and protons should be equal to one another, but they're not in this case. This one has one less. So that means this would be sodium plus 1. And we'll talk about how that was created here in just a sec. Most atoms, any normal atom is going to be considered neutral, meaning that the number of protons are equal to the number of electrons. So if we had 2 protons, we would have 2 electrons, and that equals out to 0. Okay, so you can visualize right here, the number of protons and electrons should be the same, therefore most atoms are going to have no charge. Now, we already have seen that that's not always the case, so we're going to talk about what happens if that happens. So to kind of identify a little bit more, we want to talk about the unique types of atoms. First and foremost, atoms can gain and lose neutrons. Neutrons, of course, have a mass of 1 AMU, so when we gain and lose neutrons, we're really just going to change the mass. We're going to have the exact same element, but we're going to change the mass. Gaining and losing neutrons makes what is referred to as an isotope, which we will refer to extensively in Section 2. Okay? If we gain or lose electrons, we are actually, because electrons have a negative charge, what you're going to do is you're going to change the charge of the atom, and that creates what is referred to as an ion. So if we have a neutral atom and we gain electrons, we create what is referred to as an anion. And we can kind of think about that because each electron is negative, and if we're going to gain some, we create a negative ion. And so here we see that we say a negatively charged ion because protons are less than electrons. So in this case, it would be a situation where, let's say we had 2 protons, but 3 electrons, right? These would cancel each other out. These would cancel each other out. We're left over with a negative charge, so that becomes the charge on the ion, okay? If we were to lose electrons, though, we create a cation. Now, great way to remember this is cation. ion, okay? Great way to remember the difference between a cation and an anion is cations, first of all, are positive ions, and there's actually a positive charge in the middle of the word. Also, cats are very amazing and positive in my opinion, and therefore that's how I remember it, okay? But if we have a loss of electrons, that would be similar. Let's say instead of having, so we had 2 protons, 1 electron, okay? These would cancel, leftover positive charge, therefore becomes the charge on the ion. So what I would like for you to do is summarize the notes that you took, and then what I would like for you to do is on the Atomic Basics practice packet that we started on last time, complete the first page. We've already completed the parts of an atom section and the complete the table for the elements. At the bottom, we want to do for each of the following ions, indicate the total number of protons and electrons in the ion. So I would like for you to use your periodic table with the ions that you have with their charges, identify whether they've gained or lost electrons, use that to determine how many electrons there are, and then the rest of the packet we will actually be doing most of in class next time. So I would like for you to, if you want to try 1 or 2 in each section, that's fine, but I would prefer that you not go too far into that packet to finish it all up. All right, I will see you next time.